How's it going? Ethan here with an update on the image engineering decoder reversing, I guess. Hardware is pretty much the same as far as the decoder. I have it wired into logic analyzer similar as before. Yellow is clock, pink or purple is the data. This time I'm actually plugged into an encoder, so I have the encoder feeding the decoder across a BNC video signal cable. And on top is a bench power supply, which I'm using to tickle the analog and digital inputs on the unit. ADCs and digital I/O reads it there, feeds it across the wire in video signal form. It's then decoded. I have to say much thanks to Image Engineering. I actually visited them, and they sent me away with a number of extra units which had been sitting in storage at their place. The current Image Engineering had kind of bought out the original company. They still exist. The original company that designed these I guess was in Boston. This company's in Baltimore. Even though these were designed, I guess, by the former company, the current company is building some very amazing stuff. They've got some killer stuff. Probably the most beautiful laser projector I've ever seen. Maybe one of the most powerful in the US. I don't know. I don't know what the other large companies are using, but yeah, pretty much incredible. So I guess we'll go ahead and jump into this. What I'm going to do is kind of walk through the actual inputs on the encoder, take a look at the power supply, and we'll see the change over here. Right now there are some jumping around a little bit. I believe that's just from the analog to digital converters floating, as far as there being no input signal into them currently. I'm only kind of walking port by port, and I'm mounting this on a tripod so that it's stable. So this decoder, I accidentally killed the encoder that I got. Sadly, I wasn't looking at the power supply. I was looking at the video screen and accidentally turned the power supply up a little bit too far and took it out. I'll be more cautious with this one. This is pretty much my only other chance. So this is it. I do hope to repair the other one, but it's kind of throwing me for a loop. Well, I've already done this a little bit somewhat, so what we have here is the initial thing here. The encoder can support two different scan heads. This first bit right here with the first raising of the clock line, it's currently on B. A, it ticks over one notch, so B, A, B, A. If you set it to both, where it's scanning both, it interlaces the two. Wait for it to pick it up. And there we go, we have it kind of interlacing the two back and forth. So I think it does cut the scan rate in half when running both scan heads. I'm going to leave it on B. So power supply is set, and bring it up. Now that reset, I don't know. I don't see this unit unlocked, but I think maybe the thing isn't working right. I don't know. I never hooked the other one up to a logic analyzer. Here we go. So we can see there raising of the A1 digital input. It actually brings up the 4-bit 16, 15, 14, 13, and this other bit here. So that particular one brings up the 4, which, as does A2. It moves up 1. I'll read that off in a minute as to what it actually is. So we can kind of see it function similarly. This here, similarly. This one here is moved over 1. We'll move up to A3. Now this is kind of weird. A3, we see that 16-bit drop, and it tick-tocks over to here. And then the same thing happens with the shutter input. We get the loss of the 16th, and then it moves over to position 3. Just to validate that it isn't reading all digital inputs at once. I'm on another channel, nothing. Okay. So I know that the next is blue. So for my notes earlier, input A1 is on bit 6, input 2 is bit 5, input A3 is on bit 4 going this way, and shutter is 3. So it's 1 is mode B, 2 is mode A, shutter A3, A2, A1, and then I believe the next set of 6 we're going to see is blue. So this is analog information, so you can see the voltage rides around. It kind of moves. So our blue data is right here. That is more than 6 bits. There's only supposed to be there's only 6 bits on the output side. I don't know what's up with that, so that is kind of strange. Whatever. Input green. So now we're on green. This gets even kind of stranger. We see both over in 2 separate areas here. Activity, I'm rolling up and around 4 volts. So we're in 2 different areas now. And the same thing happens with red. So red seems to be in two areas there. Now unfortunately, until I get this whole thing set up with an actual ILDA input going into it, it's kind of hard to prove that it works 100%. But so there we've got our red data, which seems kind of strange. Now we're on Y, which should be a 12-bit, I believe, on DAC. So our activity is right in here. We still have that kind of noise floating around in there as far as that, but don't know. And X. Now we're down in here, so X, Y, blue, green's kind of mixed together. Sorry, green and red is kind of mixed together and interleaved. I don't know what is up with that. And then the others. So actually, I'll switch over to A right now. So on A, we kind of see we kind of still have that same noise right in the same positions. So back on red. They're pretty much the same. They're just kind of tough. Chris Favreau had so I think our current unit here is 20 microseconds right now, and so it looks like 40 microseconds maybe between for the pause break between the actual sets of clock signals. So we see here that red data is kind of all over the place. I don't know why it's just doubled on both sides. So that's kind of a mystery there. So that's pretty much it for this update. Just kind of good to log this information here for the future. I'll try to maybe write down a little bit more of it, but I'm not sure yet. So anyways, have a good one.